Okay, so in the other video, we did some basic work with substitution, kind of the first steps on how to solve with substitution. This is going to be for some more advanced problems, including extraneous solutions like no solution and infinitely many. And so one of the things you may see with substitution is a problem that looks like this. Okay, personally, I probably wouldn't pick substitution for this problem. I would probably switch these two and then do elimination. But if you see a problem like this and you're told you have to use substitution, what you're going to have to do is in one of these equations, solve for y or solve for x, solve for y or solve for x, so that you have a y equals or an x equals that you can substitute in. Now, this one, the simplest thing to do is to solve for x, because there's no coefficient here, so I can just subtract 3y and get a new equation. So if I solve for x, this becomes -7 minus 3y. So that is my new equation that I can now substitute in up there, and I can go forward with the substitution process like we have before. Again, I'm plugging in for x this time though instead of y, and most of the time we do substitute in for y, so be cognizant of that. So if I plug in, that's going to give me 6y plus 5. I'm going to leave a blank where x goes this time. And x is -7 minus 3y. So now I'm going to do distributive. And then I have to combine like terms. So the plus -35 I just made minus 35. Okay, so then I'll add 35, go ahead and solve this. So y, after I divide by -9, is going to be -43/9. So the other thing you're going to deal with is fractions as your answers. Do not change that to a decimal because this is a repeating decimal. Plugging back in, you're not going to get things to work out exactly. So leave this as a fraction. So y is -43/9. Now we're going to plug in to get x. I can plug that in right here. That's one of the advantages to having x equals. So I have x equals -7 minus 3 times -43/9. Okay? So what I'm going to want to do is make that a negative, so I realize that I am multiplying with two negatives here. So I have -7, that's going to be a positive, so those negatives are going to cancel. And the easiest way to do this is to go ahead and multiply your fractions, top times top, bottom times bottom. Realize I can pull a 3 out of this, and so that becomes 43/3. So x is 43/3, and I still have to add -7 there, which is going to give me 22/3. So x will equal 22/3. And I can plug that back in and check my answer in these two. So again, you may have to solve before you substitute, and you are going to have answers that are fractions. We're not just going to always have whole numbers. Okay, now let's talk about extraneous solutions. You do not need common denominators when you multiply, just as a side note.
That's what I thought.
Now, this is a problem, yes, I could graph, but we're going to use substitution. So I'm going to take this and substitute it in for y. So I'm going to have 3x minus 13 equals 3x minus 11. If I zero out the variable on each side, you're going to have -13 equals -11. So just like we've done in past problems, this is not true, so this is a no solution situation. So if you do substitution and you end up with variables zeroing out and you end up with something that's not true, just like before, you have a no solution situation. Here is another substitution problem. So this time, again, I'm going to substitute in for x. So I have 3.5 times negative 2y plus 4 plus 7y. And if I distribute, I'm going to have negative 7y plus 14 plus 7y equals 14. And what you're going to see is this is going to equal 0. Negative 7 plus positive 7, that zeroes out. I'm left with 14 equals 14. That is always true. So this is an infinitely many solution problem.